At 34 kilometers of altitude, a single valve the size of a fist popped open. Within 20 seconds, the cabin of Soyuz 11 lost all its air. It remains the only time humans have died in space itself, not on the way there. In the 10th place, a pad emergency at the Baikonur Cosmodrome exposed how quickly a booster can turn into a bomb. On September 26, 1983, 90 seconds before the scheduled liftoff of Soyuz T-10-1, a fuel valve leak in the nitrogen gas system feeding the RD-0110 engine ignited a fire at the base of the launcher. Telemetry recorded a rapid pressure decay. Only 2 seconds before the entire rocket exploded, the automated launch escape system triggered, firing solid-propellant rockets. The descent module pulled clear, subjecting cosmonauts Vladimir Titov and Gennadi Strekalov to forces exceeding 15 G. Both survived with minor injuries. Number 9. On March 16, 1966, Gemini 8 completed the first orbital docking with an Agena target vehicle, only for a stuck attitude control thruster to trigger a severe roll. The spacecraft's spin accelerated to 1 revolution per second, threatening crew blackouts. Moving manually, pilot Neil Armstrong disabled the primary attitude system and activated the backup re-entry control thrusters to stabilize the vehicle. Telemetry recorded the rapid stabilization before the mission aborted to an emergency splashdown. While the Baikonur escape relied on automated ground systems, Gemini 8 demanded direct human intervention in orbit to survive. Number 8. On November 15, 1967, X-15, Flight 36597 crossed the threshold of space at 81 kilometers before turning fatal over the Mojave Desert. An electrical disturbance from an unverified payload corrupted the MH-96 adaptive flight control system, disabling the reaction control thrusters. Pilot Michael Adams entered re-entry at over 4,800 miles per hour, unaware that his guidance instruments were compromised. The aircraft slipped into a hypersonic spin, accelerating into a vertical Mach 5 dive. Under extreme aerodynamic loading, the airframe began to oscillate violently. At 65,000 feet, the structural limits failed and the vehicle broke apart, resulting in the lone fatality of the X-15 program. Number 7. On April 13, 1970, roughly 200,000 miles from Earth, an electrical short inside Apollo 13's service module caused an explosion halfway to the Moon. During pre-launch tests, a heater circuit ground tool damaged the insulation on the wiring of oxygen tank number 2. In transit, a routine fan cycle sparked the bare wire, rupturing the tank and disabling the adjacent oxygen system. Within minutes, Command Module Odyssey lost primary electrical power and oxygen. Astronauts Jim Lovell, Jack Swigert, and Fred Hayes abandoned the failing spacecraft, converting the lunar module Aquarius into an emergency lifeboat. Surviving freezing temperatures and rising carbon dioxide levels, the crew executed manual course corrections calculated by hand to loop around the Moon and return home. 6th place. On April 24, 1967, the Soviet space program suffered its first in-flight fatality when Soyuz 1 crashed in the Orenburg Oblast. The flight of Vladimir Komarov was plagued by cascading failures from the moment it reached orbit. First, a single solar panel failed to deploy, cutting electrical power in half and disabling the primary orientation sensors. The attitude control thrusters malfunctioned, leaving the spacecraft unstable as it prepared for re-entry. During descent, the main parachute failed to extract from its canister. The emergency reserve parachute deployed but quickly tangled in the lines of the trailing drag chute. Without deceleration, the capsule struck the ground at over 140 kilometers per hour, instantly killing Komarov. Declassified recovery logs show the landing system acted as the fatal failure point. Number 5. On October 24, 1960, at the Baikonur Cosmodrome, a rushed ground test of the prototype R-16 intercontinental ballistic missile triggered the deadliest launch pad disaster in rocketry history. While the rocket stood fully fueled on the pad, an electrical short circuit in the main sequencing device melted wire insulation. This malfunction sent unauthorized electrical current directly to the second-stage engine, igniting it prematurely. The resulting thrust ruptured the first-stage propellant tanks, unleashing a massive fireball of hypergolic fuel. Dozens of engineers, technicians, and military officials were standing near the active vehicle to correct a technical fault. The official Soviet death toll was recorded at 78, though modern estimates exceed 100. The disaster remained a state secret for 36 years. 4th place. On January 27, 1967, at Launch Complex 34, a routine ground test became the first fatal disaster of the American space program. Inside the Apollo 1 command module, the cabin was pressurized with pure oxygen at 16.7 pounds per square inch. An electrical spark from a shorted wire beneath the left crew couch ignited the highly flammable atmosphere. Within seconds, the fire turned the cabin into a pressurized furnace. Because the hatch opened inward, the extreme internal pressure sealed it shut, making escape impossible. Astronauts Gus Grissom, Ed White, and Roger Chaffee suffocated before ground crews could open the door. The subsequent investigation forced a complete overhaul of spacecraft safety, replacing the inward opening hatch and abandoning pure oxygen ground tests. Coming to the top 3, Soyuz 11 suffered history's most direct fatal malfunction in orbital space on June 30, 1971. At an altitude of 168 kilometers, during separation from the Salyut 1 space station, a pressure equalization valve was jolted open by the explosive bolts. Telemetry recorded a sudden drop in cabin pressure, falling from a normal atmosphere to a complete vacuum in roughly 20 seconds. The crew, Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev, were exposed to the vacuum before they could locate the open valve and manual shutoff handle. Autopsy records confirmed the cosmonauts suffocated within seconds. When the automated capsule landed in Kazakhstan, recovery crews opened the hatch to find the 3 men dead in their couches. This remains the only documented incident where humans died in the vacuum of space. In 2nd place, an overnight temperature drop to 36 degrees Fahrenheit at Cape Canaveral compromised the right solid rocket booster on the Space Shuttle Challenger. The cold hardened the rubber O-rings, preventing them from sealing the joint during ignition. At 73 seconds after liftoff, hot combustion gas burned through the compromised seal and breached the external fuel tank. The liquid hydrogen and oxygen tanks disintegrated under aerodynamic stress, killing all 7 crew members, including teacher Krista McAuliffe. The subsequent Rogers Commission investigation revealed that the booster joints lacked design margin at low temperatures. This disaster forced a 3-year suspension of the shuttle program, a complete rebuild of the booster field joints, and the creation of an independent safety office. And finally, in 1st place, on February 1, 2003, a delayed thermal protection failure caused the disintegration of Space Shuttle Columbia. 16 days prior, during launch, a 0.9 kilogram piece of insulating foam shed from the external tank bipod ramp. Telemetry and launch imagery recorded the debris striking the left wing leading edge at RCC Panel 8. leaving a small breach. During re-entry at over 12,500 miles per hour, plasma temperatures exceeding 2,700 degrees Fahrenheit penetrated the wing's internal structure. Onboard sensors recorded abnormal aerodynamic drag and a rapid thermal spike in the left wheel well before all telemetry ceased at over 200,000 feet. The superheated gas melted the internal aluminum spar caps, causing the airframe to violently disintegrate over Texas and Louisiana, which resulted in the loss of all 7 crew members. This disaster forced the development of orbital debris radar, thermal protection upgrades, and on-orbit robotic inspection standards still used today. Subscribe for more spaceflight documentaries. Across all 10 missions, telemetry exposes a chilling reality. Our survival in space depends on the smallest margins. A single O-ring, wire, or valve dictates the boundary between exploration and catastrophe. These documented failures permanently redesigned modern spaceflight. Subscribe for more forensic space history.